Don't you just love it when YouTube woodworkers try to show you how to do something using hugely expensive tools that you could only dream of owning, and then casually mention, hey, you can do this with beginner tools if you want to, but then they just move on, leaving you to ask, wait, was that a bunch of BS he just tried to feed me? Well, what if one of those YouTube woodworkers actually showed you what you can do and also showed you what you'd be missing out on so that you can decide whether the FOMO is real, or you could save yourself potentially thousands of dollars on a purchase that just isn't right for you. Deal? So recently I picked up one of the most popular job site table saws and used it in a video to demonstrate how to make quality frame and panel doors for cabinets. And it got me thinking, how much difference is there between this and my cabinet saw? What I want to know is what are the differences that can be overcome, worked around, or flat out disregarded, and where exactly is the breaking point that would cause me to throw in the towel and say, you know what, I can't do that without my cabinet saw. Woo! Daggone! That's what I'm talking about. One of the factors that I think most people would consider a big deal when looking at these saws side by side is capacity. This is a freestanding cabinet saw that weighs several hundred pounds, and this is a portable job site saw that's made to be tossed in the back of a truck. So you might think the difference in capacity was massive, right? So to break this down, I think it's actually easier to start with what is the same between these saws. Both of these use 10-inch blades, and both have over 3 inches of cut capacity at 90 degrees. And speaking of blades, both saws can utilize 8-inch dado stacks, and while the cabinet saw does have room for an additional blade, the DeWalt can still comfortably hold a 3/4 inch stack, which is better than I would have expected. But come on, the biggest difference has to be in the tabletops, right? My cabinet saw has a whopping 68-inch by 27-inch tabletop, which gives me 12.5 inches of rip capacity to the left of the blade and 36.5 inches to the right. You can pay more to have this saw with a 52-inch rip capacity, but that's not what I have, and it's not something I feel like I need for my work. The Jobby has a dramatically smaller 26.5 by 22-inch tabletop. That's 1/3 of what the cabinet saw has. But what this saw has is a telescoping rack and pinion fence system that gives you 32.5 inches of cut capacity to the left of the blade and 12 inches to the right. And with this flip over fence, you can fully support your sheet goods through the cut. So while it's true that you don't have a full solid work surface, it puts this saw much closer in rip capacity than I expected. But there's a much more noticeable difference in depth. I think having the additional 5 inches of support is great when working with larger work pieces, but I don't think it's that big of a deal when you break it down. That 5-inch difference is divided in half, 2.5 inches in front of the blade and 2.5 behind the blade at its full height. But regardless of the saw that I used in my shop, I would 100% be building some type of outfeed support because no table saw that I've ever seen provides enough support for the material after the cut. Whether you purchase an aftermarket outfeed support or build a fully capable outfeed and assembly table the way that I did, I consider this a must-have upgrade no matter what table saw you have, so that 2.5-inch difference behind the blade is really a non-factor. The support in front of the blade can be important though, especially when you're trying to make longer cuts where you have a lot of material hanging out in free space at the beginning of the cut. You could easily make an inaccurate cut here or worse, cause a kickback situation, but there are a couple ways I've found to equalize the difference between this and my cabinet saw. One upgrade I would absolutely make to this saw is to change out the stock fence for the upgraded TSO fence. It takes 10 minutes to change out the aluminum extrusion, just undoing a few screws, and this is a pretty cheap upgrade considering the capabilities that it's going to give you. For starters, you can attach things like feather boards or rolling stock guides that don't allow your workpiece to ride upward, and the rolling stock guides actually are angled inward to keep your workpiece against the fence. You can also pretty easily use jigs like a sacrificial fence for dado cuts and this in-feed support jig. This is just a strip of plywood with a couple of holes in it so that I can bolt it to the fence. And to that, I added this small plywood support piece in front of the saw. Now I have a few more inches of in-feed support for those longer cuts. There is one important difference, and that's the mass of the saw. This is a very stout saw with a solid base and weighs several hundred pounds, and this one weighs only a few dozen pounds with a mobile stand that's optimized more for portability rather than stability. I would not feel comfortable trying to put a full sheet of plywood across this saw. The risk of tipping the saw over while it's running is just too great. But here's the thing, I never cut really large sheet goods at the table saw, not even my cabinet saw. I always begin by breaking down sheet goods using a track saw first. Laying your plywood on a piece of pink foam insulation is a great way to get your materials broken down to manageable chunks, and If you want to make these cuts more comfortably, you can even get a work holding device like this Centipede, which can expand up to 4x8 to hold a full sheet of plywood and then collapse back down to almost nothing, so it takes up very little room. Yes, adding a track saw and Centipede to your arsenal of tools is an additional investment. A good track saw is going to cost you as much as this job site saw. But if you go all in on the fence upgrades and stock guides and track saw and Centipede and insulation, you're still in it for less than half the cost of a cabinet saw. So when it comes to capacity, I can pretty much work around any of the differences, including the mass and stability. The only thing I would even remotely consider a deal breaker here is having that 4 inches less of rip capacity, but I would put that at about a 3 out of 10 on my breakpoint meter. I could deal with that pretty easily if I had to. Now I want to talk about what's probably considered the biggest perceived difference between these two types of saws, and that's power. But since capacity turned out to be not that big of a deal, I wonder will power be? I kind of have my doubts, but let's see. So there's no doubt the 3 horsepower cabinet saw delivers much more power than the job site saw. But what I want to know is, where does all this raw power actually come into play in real life work, and where does the job site saw begin to tap out? So to compare these two saws, I came up with the very simple to understand test of, let's just cut some stuff and see what happens. I've got 4 stacks of different material that I'm going to run through both saws. 3/4 inch MDF, 3/4 inch Baltic birch ply, 4/4 or 1 inch hardwood, and that's going to be hard maple, and 8/4 or 2 inch hardwood, and for that I'm using white oak. And if it gets this far, I've got a secret ringer I'm calling the final boss level. To cut the MDF and plywood, I'm going to be using a crosscut blade, and for the hardwoods, I have a ripping blade. Oh, and also, these are not new blades. I've been using them in the shop for a while because I want to simulate actual real-world everyday use and not have blades that are brand new out of the package. And also, I'm kind of cheap. I didn't want to fork out the cash for new blades. What I'm going to be looking for is how much effort it takes comparatively to make the cut. Whether or not I have to slow down my feed rate to avoid problems, how clean the cut is, are there any burn marks, saw marks, etc., and ultimately, can the saw actually complete the cut? I started by making all my cuts at the cabinet saw in order to get a baseline feel. As expected, this saw had no problem cutting any of these materials. The MDF and plywood cut like butter with little effort. The hardwoods also cut really easily using the ripping blade. Definitely more effort than the sheet goods, but I never had to force the material through the saw. Alright, so here's all the cuts from the cabinet saw, and there's no real surprises here. So all of these cuts from the MDF all the way up to the white oak look very clean, everything feels smooth, and I don't see any sign of burning on anything. This is exactly what you should expect to see when you use a more powerful saw and the right saw blades, and this is going to be a fantastic baseline to compare to. Now onto the job site saw, and the MDF cut pretty easily. Even though it cut well, I can definitely hear a difference in that smaller motor under the load, where the cabinet saw just delivers constant power. The struggle became more apparent when I cut the plywood. I could definitely feel the feed rate slowing down under the load and was beginning to worry at this point how the rest of the test was going to go. After swapping over to the ripping blade, I cut the 1 inch maple and was pretty surprised that it took about the same amount of effort as the plywood. Not bad, but still about twice as slow as the cabinet saw. And then came the 2 inch oak. But you know what? This wasn't bad at all. It definitely took more effort and the feed rate was twice as slow as the cabinet saw, but I don't feel like the saw ever really struggled. And what's more surprising, I've been using a full kerf blade. So I decided to retest the hardwoods by swapping over to a thin kerf blade to see how much easier it would be. After doing this, the 1 inch maple took a full 2 seconds less to cut and was a lot closer to the cabinet saw's performance. And the improvement in the white oak was almost as much, even though it still was a bit slower than the cabinet saw. So to say that I'm surprised right now is an understatement. All in all, I think this saw performed pretty well. I mean, for most of these cuts, this is totally acceptable. This little bit of burning can easily be taken care of with sanding. This, I think, really shows what the difference between a ripping blade and a crosscut blade is on sheet goods. More teeth on an underpowered saw, and you start to see a lot more burning. Once you reduce the number of teeth and you do ripping operations, that burning slowly starts to disappear. Well, I guess that means we're going to have to bring out the ringer after all. So, final boss level, some 8/4 purple heart. I'm first going to run it through the saw using the thin kerf blade. Then we're going to switch it over to the full kerf blade. And as a last resort, I'm going to swap out the ripping blade, which is what you should use, to a crosscut blade, which has a lot more teeth. And we're going to see what that does. Honestly, this isn't much worse than the white oak. A little slower. It definitely struggled and there was a little bit of burning, but the saw did it just fine. Now let's bump it up to the full kerf blade. And that was a little slower, but the saw still lives. Okay, I guess we're trying the crosscut blade. Say a prayer for the saw. Oh yeah, listen to that. I can literally feel the saw losing its will to live. Oh, we have smoke. Get your marshmallows ready. And done. Woo! Daggone. That's what I'm talking about. I don't understand what the big deal is. I mean, that's all you ever hear about is how underpowered these saws are. But if you choose the right blade, especially going with that thin kerf blade, it cuts most materials just fine. I mean, I'll bump this up 1 for having a little bit of slowness and the occasional burning, but this is still firmly in the camp of meh, not that big a deal. The next thing I want to look at is accuracy, and to me that comes down to 2 things. Being able to dial in and hold your settings, and then reliably return to those settings over and over again as you work. The nice thing about expensive cabinet saws is that the settings are usually dialed in correctly at the factory, and the QC process tends to be more robust. And I was happy to discover that I didn't have to change or tweak anything, and after 10 years of use in one shop move, I'm still happy to report that the blade is still parallel to the miter slots and the fence, and the tabletop is still dead flat, which I guess I would expect that for how much money that I paid for this saw. But what about a much cheaper saw? What can you expect to do to get it dialed in, and are there any breakpoints here? After getting this saw assembled, I wanted to start cutting right away on some test pieces and really spend some time getting used to how the saw feels. And one thing I noticed immediately is that the piece I was cross-cutting was noticeably not square. Like, I could see it even without throwing a square on it. At first I thought, okay, well this might just be the stock miter gauge being inaccurate, so I grabbed an expensive third-party gauge that I knew I could trust, and wow, still not square. Then I ran a simple check. I used a square just to reference the miter slot, and then I set that square to just touch the saw blade at the front. Then I ran the square along the miter slot to the back side of the blade and found it was wildly off, just over a 1/16 of an inch difference. Wow. So, off to the internet I went to see what I could do about that. It must be a common problem because I found multiple YouTube videos on how to adjust the motor and the blade to be parallel to the miter slots. It's just as easy as loosening up a couple of screws here on the back side of the saw and moving it until it's aligned. No big deal. Well, I'd like to say that this comparison got off to a good start, but man, that was really out of alignment and could have been dangerous. Luckily enough, it's pretty easy to fix. Moving on. Also, if you find that no matter what you do, you just can't get the saw blade to register exactly at 90 degrees, you need to check this small cam stop. There's one of these cams on both sides of the bevel gauge, and you can just loosen those up using an Allen wrench, move the blade until you get it exactly to 90 degrees, and then you can set that cam so that it just touches the bevel mechanism and lock it back down. So far, these adjustments have been pretty easy to make on the saw, and although I wish they came that way from the factory, they were pretty easy to fix myself. But there are a few things that are a lot more annoying and not so easy to deal with. The first thing is the flatness of the top. This is one of the things that the YouTube video said to look for on one of these saws, and sure enough, mine had a couple of decent sized dips. One of the things that's nice about my cabinet saw is that it's got a top made of cast iron that's been machined flat, including the miter slots. I don't think the same thing is true for this job site saw. I think they just cast the aluminum top and then coat it with some type of protective coating. But depending on how they cast the top and apply the coating to it, this means there can be all kinds of discrepancies in the top that lead to little humps and valleys. If your top's not flat, that's just going to make it a lot more difficult to do essential things like checking to see if the blade or the fence are square to the top. One way you can overcome this is to use a larger square to set your blade to 90. The idea is you want to use something that makes contact at multiple points across the top and rides over any of those dips or valleys. If you find that you set the blade up perfectly 90 on one side of the saw, but then you transfer the square to the other side and it's not, that's because of the flatness or lack of flatness of the top. So this is obviously a pretty annoying problem to have, but one thing you can do to compensate for that is whichever side of the blade you're going to be cutting your finished piece on that needs to have that perfectly square edge, which is usually the side that's got the fence on it, go ahead and set that side of the blade up to perfectly 90 and make your cuts. The offcut side usually doesn't matter, but if you do need to reuse that material and it also needs to have a nice square edge, just flip it over to the other side, and run it against the fence and just shave off that edge until it's also perfectly square. So now that I know the blade is 90 and it's parallel to this miter slot, I need to check the fence to make sure that the fence is parallel to the blade, and also check to make sure that it's 90, and there's a quick way that you can test both of those at the same time. Just go ahead and move your fence until it just kisses the blade. Make sure the fence is locked down. So now I can test as I turn the blade, are the teeth in the front touching the fence as well as the teeth in the back, and I can actually tell there's a tiny gap here, maybe a 32nd of an inch off, which means that the fence is a little bit off parallel in that direction. The good news is this is really easy to fix because this fence attaches to the rack and pinion system right here. All I have to do is loosen up this bolt with an Allen key, and then I can adjust it by moving it forward just a bit until I close up that gap, and then retighten it back down. So now that I know the fence is parallel to the blade, I can go ahead and do the other check, which is to make sure that the teeth at the top and the teeth at the bottom are both touching the fence. If that's the case, then the fence is also going to be 90 degrees because you already checked that the blade was 90 degrees. Mine is, but I already knew that because I installed the TSO auxiliary fence already and checked that. But if yours isn't square, let me show you what I did. Back here on the back of the fence is the attachment points. It's just 2 screws over here and 2 on the other side. When I installed this, I used some playing cards as shims to make sure that this was nice and 90, and then I just tightened these up and I was good to go. The nice thing about this rack and pinion mechanism is that once you set this fence parallel, it should stay that way no matter how many times you slide the fence back and forth, and that's because both sides of the mechanism work in unison, at least on paper. But on paper is not real world, so I decided to do a simple test. I decided to unlock the fence, extend it all the way to its maximum setting, bring it all the way back in, and lock it down again, 25 times. Again, nothing scientific, but it should give me a good idea of the reliability. Oh, and I also ran the exact same test on the cabinet saw, which, by the way, was way easier on my hands than turning that dial in the rack and pinion over and over. Well, this certainly looks a lot more fun to watch on camera than it was to actually do. I just hope the DeWalt doesn't lose its settings and it's not all in vain. Or even worse, the saw stop does. How embarrassing would that be? All right, let's check the results head to head. Set the distance using the front of the blade just like before, head to the back, and check if we're off anywhere. So the cabinet saw held true, and the job site saw, I think, pretty much did as well. I think it may have been out of alignment just a tiny of a fraction of a bit, but overall, I think it did really well. But this leads me to one thing that I really don't like about this saw, and that's setting this bevel angle. On my cabinet saw, there are 2 wheels. One controls the height of the blade, and the other controls the bevel angle. And this wheel provides for a really smooth adjustment that makes it easy to get very precise angles. And on this saw, there's only 1 wheel, and that controls the height of the blade. But to set the bevel, there's just this lever lock. And when you loosen that, the motor and the blade are completely free to move with no real fine control over it whatsoever. This makes it incredibly annoying to try and set precise angles. Trying to hold my square with one hand, take a reading, manipulate this thing just slightly, and then tighten this lever back down and somehow not move it off the angle that I wanted is kind of difficult. And to be honest, this is enough to make me never want to set the bevel angle on this saw, unless I was doing something like a 45 where I could use a square as a reference or use that cam lever to set a positive stop. But another thing is, when I cut miters, I like to cut them 0.1 or 0.2 degrees off of 45, which is just an old trick to make sure that the outside edge of the miter doesn't have any gap showing. That's going to take a lot longer to dial in on this saw, and because there's no positive stop there, if you set the saw to something else and need to return to that angle, you're going to have to go through the whole process again. Another thing that's frustrating are these miter slots. They're super wide, a lot wider than what I have on my cabinet saw and what I'm used to, but also somehow the left miter slot is a slightly different width than the right miter slot. In order to use my miter gauge, I had to really crank down as hard as I could on the adjustment cams of the miter gauge to barely get it to touch the slot and have no wiggle. When I finally got it dialed in, I switched it to the other slot and the fit just wasn't the same. And this seems like one of the more difficult problems to solve for on this saw, because short of taking a file or something and smoothing down the inside of these miter slots until they both run smooth, which seems like a terrible process to have to go through, you might end up resorting to just making your own custom wooden slides that fit in each one of the slots. And then when you make a jig for the saw, you're just going to have to mark on the slide which slot it goes to so you don't get any inaccurate cuts. I also discovered that with this saw, there's a slight upward flex in the fence, especially when it's extended all the way out. This could make it more difficult to use devices like featherboards or stock guides unless you use that flip over support. But you can't use that support when the fence is over the table like this, which is when you're more likely to use something like featherboards or stock guides. So if you're making joinery cuts like rabbets, this might cause some inaccuracies in the depth of the cut. But if you're going to use a dado stack to make those rabbets, there's actually a bigger problem to avoid. So somehow I accidentally discovered that you can buy two different dado throat plates for this saw. One of them is made of plastic and the other of heavier duty aluminum. Absolutely do not buy the one made of plastic. That was the first one that I bought, and I discovered that it bows badly during cuts and is going to make any rabbet or dado cut that you make very inconsistent. So the aluminum throw plate seemed to solve my problems, and I'll leave a link to that down in the description below. But if you can only seem to get a hold of the plastic one, or you order the aluminum one and they accidentally send you the plastic one, which is what happened to me the first time, I would go ahead and stick to something like a router to cut those dados and rabbets just to avoid the inconsistencies, because man, that plastic one is bad. It does not work. So when it comes to accuracy, when you buy a job site saw like this, just expect that there's a higher likelihood of having to make some basic calibrations that should have been made at the factory. And that's an inconvenience for sure, but I was able to take care of those things pretty well myself. And while I didn't experience any issues with the saw not holding its settings, there are definitely some very frustrating flaws that I think are built into this saw. Any one of these things would be kind of annoying to deal with on a project-by-project basis, but it's really the combination of all of them where things start to feel difficult and time-consuming to try to control for all those factors where inconsistencies might creep into your projects, especially knowing that I don't have to deal with any of that on my cabinet saw. All this has me feeling not so nicey, 6.5 on the breakpoint scale. There is one other factor that I saved for last, and that is safety. And my cabinet saw has an advantage over any other brand of saw, and that is the unique ability to not cut my hands off. The flesh sensing technology on this saw is something that you could consider a big enough deal breaker, and it is the reason that I bought this over any other cabinet saw. I certainly don't want to downplay any technology that will prevent you from seriously hurting yourself. I don't want that kind of blood on my hands.
That's a joke, isn't it, Dad?
Yeah, buddy, that's a joke.
Even though there are a lot of other tools in your shop that could cause you harm, it may be worth having at least one that won't. I personally have only set off the brake on my saw twice in the 10 years that I have been using it, and fortunately neither one was due to my hand touching a spinning blade, but there's always a first time for everything no matter how much experience you have. So what do you think? Is a cabinet saw worth it, or is it a waste of money? See you next time.